है या नहीं? Slides are properly visible? Yes. Very good. Very good, students. Okay. Very good. Very good. Okay, I'm ending the results. Good afternoon. Good afternoon. Okay, focus here. So these are the contents of today's class. Okay, everyone, please be focused here. Till now, what we have studied, we have only studied refraction portion. Yeah, good afternoon, everyone. Okay, I got it. So we have wished each other. Okay, now let us start the class. So now you can see these are the contents of today's topic. What are these contents on your slides? Please note it down in your notes. Okay. Till now we have discussed what points? Okay, Shushri, note it down. So till now we have discussed what points? What are the points which we have discussed till now? If we see, we studied a refraction due to a glass slab. We have seen this thing that if you are having something like a glass slab like this, suppose this is what glasses, okay, and this is glass in front. You can see this is the glass. So if you see, if you're seeing from inside of the glass to on the other side, what you will see that there is what a shift there, and this shift is given by what formula? What formula? This is given by this S T 1 minus mu of surroundings. Mu stands for what? It means refractive index. Okay. Mu of slab at the denominator. Is it clear? Yes. Okay. One of the students have texted me something. Let us see. Yes, sir. Clear. Then we have seen this thing. If you are having a ray like this, if there is a slab like this, and if the ray is passing from is incident like this, okay, suppose the ray is incident like this, I is the ray, I is the ray, and when it is passing through the slab, it will turn somewhat and it will emerge like this. So there is some shifting, students. There is some shifting. What kind of shifting? Shifting is like this, parallel shifting, and this is known as lateral shift. What kind of shift it is? It's lateral shift. I think this was the last thing which we have completed in your class, isn't it? Please reply in the chat box. I think this is the last thing where we left in the previous class. Am I right? Yes or no? Anyone please text. Shushri or everyone like Anshu, Anshika, admin, sorry, all these other students. Nobody is from like, okay, JNB, Demetri students have also joined. Please, you can also text here. Was this the last thing? Yes. Yes, sir. Okay. So all of you are saying yes, yes, yes. Cool, cool. See, if you're participating, it's good because the session will be more interesting then. If you're like dull, like nobody's responding, so it will be like, you know, like teacher is only teaching in the class. I mean, no students are there. Got it? So see the contents here. Please now be focused. Make the proper notes. Okay, notes are very much important. If you're not making the proper notes, see what's going to happen. Now you'll understand. But you have to keep this understanding for a long time. No, that's why we make the notes. So please make it proper. So here you can see this is first. First we will be studying refraction through spherical surfaces. Till now what we have studied? Till now we have studied these things: refraction through slab, refraction through plane surface, refraction through slab which is having different refractive index. Okay, but now we'll study about the spherical surfaces. Now you might be asking, sir, spherical surfaces ka matlab kya? What kind of spherical surfaces? We have studied, hold on. We have studied till now, reflection due to spherical surfaces. What are different kind of spherical surfaces? These are concave and convex. Hai na? Okay, one of the students have texted. Yes, sir. Okay. Similarly, this, see, I'll not say perfectly concave or perfectly convex, but somewhat like concave or convex looking surfaces. We'll study refraction through that. Okay. After this, we'll be studying lenses. What is this lens thing? Lens kya hota? We'll study this. And different numericals based on lenses. Okay. By the way, this numerical which I have like shown you here at the last, this is included in this also. This is included in this also. Okay. At the end of the class, if we are left with some time, okay, we'll study this. Prism. This is the last thing in today's class. Okay. But I may include this in the next class. Prism with what? Prism with lenses. So we'll try it. Our goal is this today. At least we'll try to cover this first heading. This is refraction through spherical surfaces. Okay. No sound. Sir, voice is not audible. Am I not audible? Hold on. Hello, I'm audible now. I think I'm audible. Please mute yourself. Okay.
Yes, sir. Yes, sir.
So see now, this is on your screen. Okay, what is this? This is a refracting surface. This is what? A refracting surface. See, इसमें derivation नहीं करना. I'll give you the time to note down. No issues. I'll give you the time to make the notes. Don't worry for that. But now be focused here. What I'm saying. Okay. Main thing is this. You must be focused here. Main thing is this. You must be focused here. Okay. See, I have given this picture on the slide. What does it mean? It is just giving you the signs ki where the object is and where the image is. Remember. Okay. It is just giving you the sign that where the object is and where the image is. Is it clear now? Yes. So see, this is a reflecting surface like this on your screen. And this is the axis passing. Suppose the object is, this is object O. Okay. And from the center, this object is at distance equals to U here. And this is I image. And from the center, this is at distance equals to V. Okay. And this reflecting surface, if you focus here, this refracting surface, this one, okay, it is separating two different mediums. Remember this, it is separating two different mediums, N2 medium and N1 medium. Okay. Now, if they give you in the question, the object ka distance is given, it is equals to U, and they ask from you to find the image distance. So you will say image distance will be what? Image distance will be what, students? Image distance will be N2 minus N1 upon radius of curvature and 2 upon V minus N1 upon U. Okay? This is the formula for finding the image distance when the objects get in what? The object is placed in front of a surface which is spherical and refraction is occurring here. So I'm writing here what is happening. We know it's refraction. Refraction means bending of light while passing from one medium to another medium. Okay? Up to here clear? Why the voice is not clear? Now is the voice clear? The voice is clear now. Any one of you must at least text here, okay? Now is the voice clear or not? Okay, fine. So now I'll keep this voice only, okay? I mean, I'll not decrease it now. Fine. So see now, the next slide in front of you, I'm showing here. Note out this formula, I'm highlighting it. Please note out this formula. I'm highlighting this. Note out this formula. I'm noting it down. Okay. See, I have highlighted this. Note out this formula fast. Kar liya note? Yes. Let me see some chat. Okay, it's fine. So write the key points also. I'm highlighting. See, these are important points for using this above formula. What are the points? The points are this. See, this formula is valid for paraxial ray. Paraxial ray का मतलब क्या होता है? Paraxial ray means the rays which are near to the axis, having short angle. Okay. UVR you have to put with the sign. UVR here you have to put with what? Put with the sign here. ठीक है? Mu2 is for what? Medium in the rays in which the medium, like its mu2 is the medium in which the rays are going. Okay, and mu1 is the medium from which the rays are coming. Rays are coming. Okay, so one thing I'm writing here, hold on. Rays are going का मतलब towards the image. This mu1 is for object. Mu1 is for object here. ठीक है? So now based on this formula, solve this question. I'm giving you time. Based on this formula, solve this question. So this is a class illustration. See here. CLASS illustration. Solve this question. Try to solve it. Okay, so this is a first illustration. So I'll be solving it for you. Okay. Taking this as a model illustration, try to solve the next one. So I'm solving it. Please be focused here. You can see here what are the conditions given. This is what kind of surface? It's a refracting surface. This is refracting surface. And this is object, which is at 30 centimeter from the center point. Okay. And image. See, we say it's V is the image distance. Suppose it's forming here. Image. Okay. They're asking us to find this V. Okay. And refractive index of this inside medium is given as 1.5. And refractive index of this medium is given as what? 1 here. Radius of curvature is given as 10 centimeters here. Okay. Radius of curvature here is given as 10 centimeters. So I am solving this. Please be focused and see for you people, actually the hint is also given here that they have given the sign and conventions with the object distance and radius of curvature. See, this was a refracting surface. Radius of curvature is say plus 10. Object is at 30 centimeters. Okay, this is the object distance. You know the formula is what? This medium is having refractive index as 1.5. This medium is having refractive index as 1 here. If you apply the formula, this is what? N2 minus N1 upon radius of curvature. N2 upon V, N1 upon U. Okay? If you subtract this will give you what? 1.5 minus 1. Very good. So Sonali have already given the answer. This is what? 90 centimeters. Okay, let us check it out. Is this 90 or not? So here if you'll see 1.5 minus 1 is how much? 0.5. It means half. Radius of curvature, you have to put the value as plus 10 centimeters. Okay? N2 here is 1.5. V, I don't know. I need to find. N1 is 1. U is given as minus 30 centimeters. Simple. Just put the values. So you'll get here. Let me use different color. So you'll get here answer as 1 by 20. N2 is what? 1.5 upon V. N1 is 1, okay? And U is minus 30. So this is 1 by 20 And if you solve it, this will be minus 1 by 30. This will be 3 by 2v. This is how much? If you solve it, you will get the answer as 3 minus 2. Okay. So this will be 1 by 60. This is equals to 3 by 2v. So this is equals to 30. And yes, the final answer is 90 centimeters. So all those students who got this answer, please text in the chat box. Let me see. So how many students got this answer? 90 centimeter. I am audible. How many students got this answer as 90 centimeters? Okay, Sonali, you got the answer. Barsha got, Sandhyarni got. Okay. So almost all the students, I think they are able to find this answer. Okay, that is 90 centimeters. So what's the conclusion? Conclusion is this. Let me show this on the next slide. Yes. Good, good. So the conclusion is this, that if this is a refracting surface like this, and the object is present at a 30 centimeter distance from the center, image after refraction due to this refracting surface will be forming somewhat like this, and the image distance will be 90 centimeters. This is V. V will be plus 90 centimeter. Okay, this is the last, like, the final conclusion of this, the solution of this question. Fine, students. Let us move towards the next question now. Okay, now solve this question and try to find the answer using the previous question as a model. I mean, use all the strategies which we applied in the previous question. But don't forget to put, like, you know, what the values of object distance U, V, and R, that is the radius of curvature, with sign and conventions. Never forget that. Okay, it's very compulsory. Otherwise, what's the use? You know the theory, you know the concepts. You forget to put the values with the sign and convention. It will not work. Try to solve this. I'm giving you few seconds for this. Okay, your time starts now. I want the answer. I don't want you people to show me that how you'll draw the ray diagrams. Erase this. I want only this answer. Find the V. Find the V here. What will be the V? Image distance. Okay? Your time starts now. Okay, since nobody have texted, so okay, I'm assuming that you don't know how to solve it. Okay, so I'm giving you the answer here. See, first of all, let us focus on this refracting surface. Is this, where will be the radius of curvature's direction? You can see this refracting surface, it's curved in which sense? It shows you like this, that the center of this refracting surface will be somewhere in this direction. So we'll give the sign as what? Now we'll take this R as minus 10 centimeter. Now we'll take this R as minus 10 centimeter. Okay. And if you see the object distance you will take here minus 5 centimeters. The radius of curvature as minus 10 centimeters. And two, okay, one of the students have texted me. Okay, so Sonali Biswal have texted 0.6 centimeter. Excellent. Okay, so you find it out, like, so students, you have, like, what's the quality you must have? You must possess. It must be like this. You must be like fastest and accurate. Okay, so we'll check that answer is 0.6 or not. Just wait. We'll check this thing. Is the answer 0.6 or not? And two is how much it is? 1.5 here. So see, you can note down the solution as I'm solving here, okay? Side by side. N1 is what? 1 here. Clear? Find the answer. Simple. Find the V value. Apply this in the formula. N2 minus N1 upon radius of curvature. Okay. So Suryadip got the answer minus 6 centimeter. Okay. So you can cross check yourself the answers. Is it 0.6 or minus 6? You have to wait for my solution. Okay. Ultimate answer here. So this is N2 okay. This is N2 minus N1. This will be N2 upon V minus N1 upon U. If you see N2 value, it is 1.5. 1.5 minus 1, radius of curvature is okay, students. There was some technical issue. We are back now. Okay, you're able to see the screen. Are you able to see the screen? Yes or no? Okay. So see, this was 1.5. The voice will be audible. Don't worry. The voice is audible. Okay. Is the voice audible now? Yes or no? Reply in the chat box. Shushri, I think the voice is audible now. Reply in the chat box fast. Okay, it's clear. Yes, okay. So here, this is 1.5. This is, okay, Barsha, cool. This is 1.5. This is minus 1. R is what? If you see the radius of curvature, kitna hai? It is 10 and it's negative, okay? So minus 10 I'll be using. N2 kitna hai? N2 is 1.5. V is V. N1, 1. U is what? It's negative or positive? Negative minus 5. Find for V. What is the answer V? Now check the answer. Minus 1 by 20, 3 by 2V plus 1 by 5. This will give you the answer as minus 1 by 5, 3 by 2V. If you find V value, क्या होगा V value? So this is plus or minus. First of all, see the signs. 4. Okay. And this is 3 by 2V. This will be minus 5 by 20. This is 3 by 2V. This is 5 1 5, 5 4 20. Finally, this will give you minus 1 by 4, 3 by 2V, 2 2 4. Final value of V will be here is equals to how much? Minus 6 centimeter. And this is the final answer. Okay? V equals to minus 6 centimeter is the final answer. So how many students got 6 answers? 6 centimeter is the answer. Let me see. Only Suryadip Maharana got 6 centimeter as the answer. Sonali, maybe you have done some mistake. Like you took a point, I don't know from where you took this 1 upon 10 factor and multiplication with, 6 centimeter. Okay. Now I think that you all got, maybe you have done by mistake. Sonali, so check the calculation. Maybe by mistake you did this thing. Okay. Rest of the answer is fine. It's 6 centimeter, not 0.6. So, this is also thing which we are learning in the class illustrations. What we do is this, by mistake, we know everything, concept and the formulas. We know the application of the formula also. So we are applying this, and in hurry, what we do? We make a mistake, mathematical mistake, and it's same if that you don't know what the concept is, and you're not able to attend the question. Got it? So be very careful. Even if you are good in concepts, you're good in knowledge, you're good in theory, you have to be accurate In which region? I mean, you must be mathematically accurate. Okay. So until and unless you get the final answer, don't run. Okay, ma'am. Don't like give the answers like this. Got it? The right answer is 6. Now let us move towards the next question. So you can note this down now. This is a new theory topic for you. Velocity of spherical refraction. Matlab, if a spherical surface is moving, then in that case, how you'll be finding what? The images of the object and the speed of the image, the speed of the image and speed of the object. Okay. So here one student give, see, only 2 students are giving the answer. Sonali and Suridip. Okay. Both of them have given the correct answer, just a little bit of the mathematical mistake. But what about the other students? Barsha and like all other JNB, then Demetri students. What about you? So all of you must participate in the class. Okay. Only 2 students are giving the answers accurate. Okay. So now this question, I mean, this is a theory topic. See, no need of derivation. You can note it down the formula now. Derivation will be given on the PDF. Okay. You can note it down afterwards. But the main thing is this formula now. Remember it. See, if we talk about the rest of the things, hold on. If we talk about the next of the things, we have seen a plane mirror. An object was moving in front of the plane mirror. We have derived the formula for this also. That velocity of image plus velocity of object upon 2 is what? Velocity of mirror. Okay. Similarly, when there is some refracting surface like this, and refractive index 1 is for this medium, and on the other side it is N2. In this case, we know how we find if the object distance is given as U and the image distance is given as V. How we'll find this U and V values? What's the formula which is connecting both of these? Anyone? Yeah, this is this formula. N2 minus N1 upon R, radius of curvature will be in this direction. N2 upon V minus N1 upon U. Okay? Is it fine? Okay. So now what you need to do is this. If you'll differentiate this formula on the LHS side, that is left hand side, and the RHS, that is the right hand side, with respect to time derivative, you'll get this highlighted formula. This is what? This will give you the velocity of image with respect to the ground frame. This will give you velocity of refracting surface. This will give you velocity of object. This will give you velocity of surface. Okay. This is N1, N2 refractive index of 2 different mediums. This is V square upon U square. This is image distance. This is object distance. Got it, students? Remember this formula. Okay, if you have like if you have noted down this formula, apply in this question. So this is also class illustration for you. CLASS. Okay, illustration. Apply this here. I'm writing this formula for you. N2 minus N1 upon R, N2 upon V minus N1 upon U. Differentiate this, get like this. Velocity of image minus velocity of surface. Okay. Next is what? N1. N1 upon N2. V square by U square. Velocity of object minus velocity of surface. Okay. Few hints I'm giving you for solving this question. What are the hints? Hints are these here. Okay. So hints are these, that velocity of surface means refracting surface. Velocity of refracting surface here will be 0, ठीक है। वेलोसिटी ऑफ रिफ्रैक्टिंग सरफेस क्या होगा, 0 यहाँ पे, ठीक है। एंड ऑब्जेक्ट वेलोसिटी विल बी व्हाट, इट इज मूविंग विथ हाउ मच स्पीड, इट्स +2 मीटर पर सेकेंड। Velocity of image, we don't know, we need to find it, ठीक है। Apply the formula. Now I think this many hints are, it's more than enough. You can cancel this vs factors, this will remain. Find the answer. Conventions, use yourself. If u is negative, still the square will be positive. N1 is what, air. N2 is what, 1.5. What do you think, what will be vi? Text your answers in the chat box, I'm waiting for you. Okay, so some of the students have participated. Let me see the chat box. No one has given the answer. What do you think, what will be the answer of this? Just, I want vi value. I think you all are solving. First of all, you have to find this v from this equation. Then put this v here, it's square. You'll get the answer. So, okay, it's good. So somebody have responded. It's really good, okay. So Manarani says 6 answers. Excellent, okay. I think this is the answer. Let us check it out. Anybody else? Anybody else? Anshika has given a 6 answer. Excellent, Anshika. Very good. So you people are really working hard, okay. I mean, you're like, it must be, I told what, fastest and the accurate. I'm solving now. So, okay, one more student have given the answer back to back. JNV students have given, Demetri students have given us 6. Very good. So I think 6 is the answer. Let me solve this. See, this is what N2 minus N1 upon R, N2 upon V minus N1 upon U. N2 is 1.5, N1 is 1. Radius of curvature is how much? It is 10. It's positive here, okay. N2 again is 1.5. It's V here. N1 is 1. U is how much? We are taking here to be minus 30. Plus हो गया, ठीक है. This will be 1 by 20. This will be minus 1 by 30. This will be 3 by 2V. From this, you will get V value to be how much? If you solve it, the left and the most leftmost side will give you the answer as कितना देगा? 1 by 60, 3 by 2V. This will give you the answer as V equals to 90 centimeters. Yes, very good. So now simple, put the formula, will put this V value in the formula. Formula is what? N1 upon N2, V square upon U square. We know Vs was deleted from this. Vs we got at 0 because that refracting surface is not moving. Okay, so that's a good point for us. Okay, I mean the calculation becomes easy. This is velocity of object. This is what? Image or object? No, it is image. This is velocity of image. This is velocity of object. Okay, image, I don't know. Object is moving with what velocity? It's +2 meter per second here. Okay, N1 कितना है 1, N2 कितना है 1.5. V is what? 90 U. कितना है? V value is what? It's 90 centimeter. We got it. 90 square. U is what? 30 square. 2 multiply. Okay, so now you are saying answer is 12. Let us check. Just have patience. Okay, we'll check. So VI magnitude we want. Okay, simple. This will be 3 by 2 means 2 by 3. Okay, this will be 33. It means it's 9 here. 3 3s are 9. So we get 2 into 3 into 2. This is how much? It's 12 meter per second. So finally we are getting this VI magnitude as 12 meter per second. That is, if the object which is in front of the mirror, see, look here carefully. This was the object. Yes. Swapna and Sonali have given the right answer. Students, you missed again. I think again you did calculation mistake. You must multiply by 2. 2 factor, I think JNV Demetri students and Anshika and Manarni and you people missed 2 factor. Please cross-check your cross-check your calculation. The process is fine. I mean, equating the equations and all this thing in the formula. Okay? Fine. So this time you have given the right answer, Sonali and Swapnik. Okay. So object is moving with speed equals to 2 meter per second. And the image here is moving with the speed plus 12 or minus 12. It's plus 12. Like this, 12 meter per second. So this will be a very cool picture in front of you. You can see. This is the picture in front of you. Clear, students? I think it's clear. 2 meter per second and 12 meter per second there. Two and 12. It is clear? Okay, let us move towards the next. At last, you can write this heading of transverse magnification. See, we have studied the magnification in case of spherical mirrors, that is concave and convex case. Okay. So write this formula for transverse magnification. What is it? What is it explaining you? It is explaining you like this, that if this is a refracting surface, okay, and the object is in front of the reflecting surface, which is at distance equals to u. Okay. If the object's height is also given h0, and image is at distance equals to v, and the image height is also given. Okay, so if you want the connection between the heights and the linear distances, you will use this magnification formula. Derivation is for only those students who want it. It will be given on the PDF. Okay, no need to go in the depths of this because we are not going in subjective sense. We want what? You know, JEE exams and KCT and NEET are what kind of exams? These are objectives. Okay, got it? Fine. Any doubts? No. Have you noted this down? Oh, so let us proceed towards the next slide. Please put a text in the chat box, yes or no. So we can proceed towards the next. Anyone, Shushri and all the students, I mean, Sonali, Janvi, Dimitri, and Shik and all the students, please reply in the chat box. All of you must reply, okay, not these only. Okay, so I am moving towards the next now. Okay, Monarni says yes, cool. So now students, this question in front of you, it is based on the combination of, see, earlier we have solved a question, if I tell you, earlier we have solved the questions which were based on combination of concave mirror and plane mirror, concave and convex mirrors. But now this picture is different. Now we're using the combinations of refracting and reflecting mirrors. Okay, combinations of reflecting and refracting. I'm writing here. Okay, you can note this heading. We are using the combinations of refracting and reflecting mirrors, or you can call reflecting surfaces. Okay. So see, you can see this on your slide. This is the question. So try to solve it. Okay, one of the students have given the answer. So okay, fine. So now we'll see here how to solve it. Okay, suppose you're having a refracting surface like this. Okay, this side is having medium which is having refractive index as 1. Okay, and on the other side, this is a medium which is having refractive index as 1.5. Okay, see, you are having this radius of curvature of this material. I mean, the surface, refracting surface is how much? It is 10 centimeter. You can see on your screens. See, two things can be noted here. Key here, one is the refracting surface, and other surface is what? Reflecting surface. This is what kind of surface? Reflecting. This is what? Refracting surface. Okay. This is what? A plane mirror. A plane mirror. Got it? Okay. What's the doubt is? Okay, so you got the answer 30 centimeter back of the plane mirror. Sonali, so you're doing so good. I mean, it's excellent. But this is just first answer. I mean, here the complete question. Okay. It's good you have solved, the answer is right. But we have to take in this question 3 images. And the third image which will form, that is the answer of this question. That is the demand of this question. I mean, if the questioner is asking the question, he's saying you find I1, I2, I3. And I want the images to up to the what? I3. Because see, if you consider reflections and refractions here, first the ray will go from here. It will form the image here, I1 image. Then is mirror make reflection hoga, I2. Then again, that virtual image which is in the mirror will act as a virtual object. I mean, the rays are appearing to coming from that object. That is the image in the plane mirror. For this again reflecting surface. So it may happen no again and again the things will be going on refraction, reflection, refraction, reflection, reflection. So what they're saying, you only have to find first refraction, reflection, and refraction. I3 image. So they're asking up to the third image. What is the answer? Up to third image they're asking. Okay? Got it? Okay, don't worry. No need to worry. I'll be solving this here. Complete question. Then we'll end the class. Okay? So see here carefully. This is a surface here. It's like this. Let me erase this. This is a surface like this. This is the plane mirror. Okay, if you focus here, this is having refractive index as what? N1 equals to 1. This is R equals to 10 centimeters. Okay. You can see here the object is present initially in front of it as 30 centimeters. Okay. And here this is at 120 centimeter. N2 is how much? 1.5. You can see this is plane mirror. Okay, now let us proceed towards the solution. Okay. See, first I will draw the ray diagrams for you. Okay, if you see the ray diagrams, if you just focus on the ray diagram here. See, focus on the ray diagrams, okay? So this is the object. Rays will be going like this. And it will get refracted. And somewhere these rays, I'm just drawing for the sake of convenience, only 2 rays. For the sake of convenience, only 2 rays. And the rays will get refracted and will meet here like this. So through this, you will get the first image I1, not I2. We need 2 more, I2 and I3. So I1 image, if I apply the formula, you know what the formula is? N2 minus N1 upon R. N2 upon, what is this? V or U? What do you will say? V minus N1 upon U. Put the values. N2 is 1.5 minus 1. Radius of curvature is कितना होगा? Plus 10 centimeter. N2 is what? 1.5. ठीक है? V कितना है? V we don't know. N1 is how much? N1 is 1. ठीक है? U is how much? U is minus 30 bit conventions. Solve it. What is the answer? Anyone is 1. क्या आंसर आएगा? Anyone? This will be 1 by 20, 3 by 2v plus 1 by 30. So when we will solve this 1 by 20 minus 1 by 30, we'll get the answer as, okay, one of the students have given the answer. 90 centimeter. Excellent, Barsha. Your answer is right. So we'll solve this thing. You'll get it, the answer as 1 by 60, 3 by 2v. So v from this I'm getting as 90 centimeters, which is the right answer. V here is equals to the 90 centimeters. V kitna students? V is 90 centimeters. Fine. So I'll tell like this. Positive hai, positive. It means this direction. So I'm getting this V here, 90 centimeter. I1 image. Now listen. It's not finished. Now this I1, which is the first image, will be acting as what? Which object? Like a real object. It will be acting as a object. It will be acting as an object for this plane mirror. So remaining distance is how much? Remaining distance is how much? It is 120 minus 90. 120 minus 90 kitna hota hai? It is 30 centimeters. So I will write here it is 30 centimeters. Okay. So now this I1 image will be acting as an object for this plane mirror. And you know this thing. The question will become now like this. That suppose you are having a plane mirror like this. This is what? A plane mirror. Okay. An object is present in front of this plane mirror at 30 centimeter distance. And we know the concept. If the object is present, yeah. So that's right. Your answer is position I3 is 25. Excellent. So Manarni, your answer is, it's the accurate answer. Okay. It is 25 centimeter behind the mirror. So if we see here, we know the plane mirror concept is this. If the object is present in front, image will be 30 centimeter at the back. This is I2 image. This will be what, students? This will be I2 image. So now this image, we know since it is inside the mirror. So this is what kind of image? It is virtual image. Okay. This will write here as virtual image. Okay. So now let us complete the question. This was a refracting surface. This was the plane mirror. Now we are having the I2 image at 30 centimeter. I mean, inside the mirror. Inside means what? Behind means what? It means virtual. Fine. So now this, which is the image, will be acting as a virtual object for what? Virtual object for this refracting surface. Okay. Virtual means what? Like the rays will be appearing to come from this kind of object. That is I2. So the rays will be going somewhat like this and reflection will occur. And final image will form. It will appear to come from this. It is not actually coming, but it will appear. That's why we say what? It's virtual. So you'll draw the rays here and finally the images will meet here. This rays will meet here, sorry, okay? And you will get I3 image. Apply the formula. Here distance kitna tha? It is 120 centimeters. Fine. Apply the formula. This is 1.5, this is 1. R is, now R you will take with sign and convention as positive or minus? Negative, because we are going against the rays direction. So it is minus 10. Object distance, of course it is negative. How much? Total is 120 plus 30 equals to 150. Okay. Apply the formula. So you can see here N2 minus N1 upon R, N2 upon V minus N1 upon U. See students, you can see now the mediums are changed, by the way. If you focus here in the question, the mediums are basically changed here. How? So now you will say N1 is this and N2 is this. N2 is 1 now. Put the values, fine. Put the values, put the values. N2 you will take what? N2 क्या लोगे? N2 क्या लेना है students? 1 minus 1.5. R is minus 10. N2 is 1. V minus, because in that side the reflection is occurring. Okay. 1.5 upon U is how much? Minus 150. Okay, u is how much? Minus 150. Solve this question. This is 0.5. मतलब 0.5 का मतलब क्या हुआ? It is minus half plus 20. Okay, this is 1 by v. This will be plus 1. This is how much? If you say it will be 100. Okay, plus 1 by 100. Fine. Solve करो इसको. You'll get 1 by v value as 1 by 20 minus 1 by 100. This will give you the value as how much? 1 by 5. Okay, so if you'll completely solve this, we'll get the final answer as 1 by 20, 4 by 5, 4 by 100. Okay, is it fine? This is 25. Who has given this answer? So finally you'll get I3 image as 25 centimeters distance. It means if the object is in behind the mirror, like virtual 150 centimeters, images will be going like this, and finally you'll get this at 25 centimeters. Final answer, I3 image. Fine, students. So if I show you in the main figure, see if I remove all the things from this, how can I show this? First, I1 at 90, then I'll say I2 at 30, then I3 at, say it's 30, it will be less, I3 at 25 centimeters. These are the 3 points of the 3 different consecutive, like, side by side images. Fine. And this is our ultimate answer, I3, 25 centimeters. Is this concept clear? So we can end the class now, students, if this is clear. Okay. Okay, so before ending, let us, I'm launching a poll, please participate in that. So today's goal we have achieved. We understood how the refraction will occur via what? A refracting surface, whether curved like this or curved, bulged in or bulged out. Okay. Our goal is completed. In the next class, we'll start with the lens and the prism. Okay. Okay, Shushri, bye everyone. Study well, be happy. Try different kind of, modules. If you're not having the modules, solve HCV. HCV concept of physics part 2 for ray optics. Okay, bye everyone. Bye students, please participate in this NPS and then you can leave. If you're having any doubt, you can text in the chat box. If you're having any doubt, you can text in the chat box. Okay. Bye everyone. We'll meet in the next class. Okay. Bye Varsha. Bye everyone. Okay. If you all have participated, then you can leave. Okay. Any doubts, you can still text in the chat box. I haven't ended this class. Okay. I haven't ended the meeting. You can still participate in the chat box if you're having any doubt. Participate in the NPS and then can leave.